What do you do if you have a tiny little microcontroller like this Pico 2040 and this big old motor? This is a 550 style motor, it can draw about 20 amps, but how do you control the two? Between the two, you have what's called a motor controller. In this case, a BTS7960, which is a really neat guy that you can get off of Amazon for like 12 bucks, which is crazy considering most motor controllers only that can power a motor this size are going to cost like $40 plus. So this guy's really exciting. I like using them, and I'm going to show you how you can wire it up to a motor like this and wire it to your microcontroller and control it. So with that, let's go. So the first thing that I'm going to do is I'm going to wire up the battery and the motor to this guy. So this giant screw terminal has 4 inputs. The battery plus is all the way over to the left, my left, your right, and then battery minus, and then motor input 1, motor input 2. The motor, since this is a DC motor, doesn't really care which way these wires go. It's just if it's flipped, if the motor starts running flip from how you want it to, just flip those wires and it'll go the right direction. So yeah, let's get these plugged in, and these are marked on the bottom there as B minus, B plus, then motor plus, motor good. Now we can hook up from the Pico over to here. So there's 8 different spots in here that you could hook up to. We really only care about 5 in this configuration. So this first spot right there is labeled as ground. So ground is going to get connected over. It's always important whenever you're trying to control something like a microcontroller or a sensor that you have that ground connection. That way the electrons are flowing. So I'm going to hook that up to ground. And then the next spots on here are L, labeled as LS, and RS. So those are current sense pins. The BTS7960 will let you know approximately how much current is going through and alert you if it's going over current, which is actually really nice for such a cheap microcontroller or motor controller. The next pins that we do care about are the R enable and the L enable. So basically how this is set up is there's actually 2 7960 IC chips on here, and it's set up in an HRID configuration. So really the L channels are going to one IC and the R channels are going to another IC. You have to be really careful about them fighting each other. But the R enable and L enable pins, you can just cut off the power going to the IC using those. But I don't really care about that, so I'm just going to tie those directly to the plus 3 volts on the Pico. That way the motor will always be enabled. But if you want to have some extra safety controls on there, I would definitely recommend hooking them up. And the last pins, which are going to be our control pins, are the LPWM and the RPWM. Now those are what actually control the speed of this. And now this is really important. You need to make sure that you're never turning both of those on at the same time, otherwise your motor is going to start fighting and you might burn out the IC. So anytime in your code, make sure you write those to be, or if you're going to want it to go right, turn off the left output. If you want it to go left, make sure you turn off the right output first. So I'm going to wire these 2 pins 14 and 15 on the Pico, and then we should be good to write some code. Alright, so I'm going to do this in Arduino. You can program a Pico in Python or a couple other different ways, but I like using the Arduino system. If you guys want me to make a video of how to set up a Pico in Arduino, let me know in the comments. I'd be happy to walk you guys through that. So I'm going to make some macros so I don't have to constantly remember the pin definitions. I'm going to call this RPWM, set that to 14, and then define LPWM, set that to 15. Then I'm gonna go to setup, make sure pins are set up as outputs. So I'm gonna go pin mode, and then RPWM, put, pin mode, LPWM, output. Boom, double check that compiles. It's working. Boom. All right, so let's actually get these to do something. So I'm gonna use to get some PWM output. So PWMs are just signals that are turning on and off really rapidly. I'm gonna use the analog write function. Analog write. Give it our pin. So RPWM. I'm gonna set this to 0. We're gonna start off going left, and then LPWM. I'm just gonna set that to 50 so we're not going too fast. So the second input on the analog write function is a value between 0 and 255. 255 means that that signal is going to be always high or 100% output on the motor. So when I'm setting it to 50, I'm setting it about to 20% speed. And ship that over to the Pico. While that's doing, I'm going to hook up some power. So this is coming from a power supply. Right now it's off. It's really useful to have something you can turn on and off easily whenever you're working with a motor controller, just for safety. So if it starts running and doesn't stop running, you have an easy way to turn it off. Now, looks like my code failed and I can't spell analog. Right, I should just upload that. Arduino complaining at me. Boom, that worked. All right, so I'm gonna turn on my power supply and the motor should immediately start turning. Boom, done. And it doesn't stop. So you can see it spinning there. So let's add some code to turn it off and switch directions real quick. So I'm just gonna add a delay here, 1000, so 1 second, grab all that, copy it, put there, put it, okay, so let's directions, and I'm actually gonna switch the order there just to be sure that I'm turning off the LPWM before I turn on the right. And then to get them both to stop, I'm just gonna set them both to 0. So we'll go left for 1 second, and then go right for 1 second, and then stop for 1 second. Let's give that a whirl. Let's give it some power. Might be kind of hard to tell on the video, but it is, I swear, changing directions. All right, cool. So that is kind of useful, but what if we want to have manual control instead of having to upload new code if we want to change the speed on this? So what I'm going to do is I am going to add a potentiometer to the circuit so we can get some speed control. So I'm just going to plug this directly into the breadboard. So it'll go like that. And then I'm going to take one wire, make sure that's lined up with the pin. And then I'm going to plug that to be ground. Take another wire. I'm going to plug it into the middle. So this is our signal, or it's a varying resistance on there. And I'm going to hook this up to pin 28 on the Pico, which to have an ADC, which is an analog to digital converter, which basically lets it read variable voltages. And then we're going to hook up the last pin on our potentiometer, and we're going to plug that into our power rail. All right, so now that we have the signal and power and ground hooked up on our potentiometer, we can add some code to do this. So starting out, I'm going to make another definition, and I'll call this the pop pin, because potentiometer is a long, ugly word. Pop pin. I'm going to make sure it is set up as an input. Pop pin, input. And I'm going to get rid of all of this. I'm just going to directly write, or analog read this time, the pin. So analog read returns a value between 0 and 255, which conveniently is the input into analog write. So we're just going to directly write whatever is being read on the pop pin into the LPWM. Get that uploaded. I'm going to make sure this is spun all the way to ground so it doesn't immediately fly off the table. Boom, done uploading. Get some power. You can hear it trying to turn, so the ADC is probably reading a little bit of voltage and not all the way to 0. But if I turn potentiometer, you can see it starting to spin up. It can go all the way. Hear it burr. And we can take this all the way down. And you can still hear it trying to go. So I'm going to add a little bit of code that makes sure the potentiometer, when it's all the way to the side, actually sets the motor to 0. So I'm going to do this by creating a integer variable, call it val equals, take that out, set it equal to the pot pin, and then we're going to add an if statement. So if val is less than, we'll say 20, we're just going to go ahead and set val to 0. Then we're going to come back down, drop val into the LPWM signal. It should be good. Give it some power. And hey, it's not moving, which is a good sign. And then we can turn it up, way up, and then set it down to 0. And it is not trying to move. So that's the basics. If you guys like this kind of content, go ahead and hit that like and subscribe. I know to keep on making this, that's like the main so I know that this is useful stuff. And if you have any specific questions or you have ideas for other video tutorials that I should make around robotics, let me know in the comments section. I would love to hear them and just keep on getting better ideas. But yeah, have a good night.